Okay, why is it like this one? Because the two electrons have been removed from the S. We have to see whether it is in the first period or second period or the fifth period of the periodic table. Now let's see this one, the strontium. Oh, strontium. Yes, this one. This is uh, 1, 2, 3, 4, 5. So 5s2. Strontium is 5s2. Ending is 5s2. And then so the two electron from the 5s2 removed. So leaving with 4d. Right? There is 4p. And then there is the 5. So the two electrons in the outermost shell removed. So leaving the inside. And then we know that the radius is calculated from the inner to the outermost. So
So when the electrons are removed, it means the shell is also gone.
yeah, of course,
Oh,
because yesterday there was a question like 4D or like calcium. Calcium we know until 4s2, but there was a blank 3D. What is the value? It is 3D 0, meaning there is a subshell, there is orbital 3D orbital, but it doesn't contain electron. So it is the outermost is from counted from the nucleus to the 4s.
okay, teacher. Thank
Okay.
you, teacher.
Yes. Now, for the 23rd, I've prepared 5 pages. The alkali metals are series of 6 elements in the group 1 periodic table. The first ionization energy of these elements shows a marked trend. Marked trend as the group is descended. Define the term first ionization energy. What is the term of the first ionization energy? Let me ask to let me ask let me ask to who ya? Let me ask to Ariela. Hello Ariela.
Yes, teacher.
Okay. Define the term first ionization energy.
The energy required to remove completely 1 mole of electrons from 1 mole of gaseous atoms.
Yes, correct. And then state and explain the first trend, the first ionization energy as group 1 is descended. So it means goes down the group. Okay, let me ask to Beatrix. Hello, Beatrix.
Yes, teacher.
Yeah, state and explain the trend in the first ionization energy as group 1 is descended. So down the group.
Uh,
The first ionization energy decrease or increase down the group.
in Greece. In Greece.
No, it is decreasing. First ionization energy, group 1, down the group, decreases. Why is it decreases? Because,
There's shell in
because,
electron shell. There's more electron shell.
yeah, if there is more electron shell, what is happening?
Radius increase.
The radius increase, and then what is happening? What happens with the shielding?
More shielding.
More shielding, and then what happens with the nuclear charge?
More with no less.
Less nuclear
Less.
charge. Less nuclear charge make the less first ionization energy. And then number 3, the third point, B, second point, suggests how this trend helps to explain increase in the reactivity of the elements as the group is descended. Let me ask Bavia, how the trend to explain the reactivity in of the elements as group 1 is descended.
As we go down, the reactivity increases
Because
because when electrons can be removed more easily, it is more reactive.
yes, correct. As goes down the group, less nuclear charge, easy to lose electron. The electron makes the reaction occurs. And then C, in the
Teacher, can you
redox,
repeat that?
yeah,
Can you repeat the answer before?
answer uh, goes down the group 1, nuclear charge decreases. Electrons easy to lose. Electron is the subatomic particle that responsible for the reactivity. And then C, in a redox reaction, 0.83 of lithium reacted with water to form 0.5 liter of aqueous lithium hydroxide. Calculate the amount in moles of lithium that reacted. Let me ask to let me ask let me ask to Vedika. Hello, Vedika. Yes, Vedika. So, amount of moles of lithium that reacted. Lithium is this one. This on the data booklet. The relative atomic mass is 6.9. And then this one. What's the amount? The amount of moles?
0.80 divided by 7, 0.199 mole,
0.
119 mole.
Yes, 119 mole, or it is can be rounded off become 0.12 mole. Okay, next this one. Okay, next calculate the volume of hydrogen produced at room temperature and pressure. Let me ask to Vanessa. Vanessa, from the equation here, this equation, Vedika found the answer of the mole is 0.12 mole. And then what is the volume of hydrogen gas produced at room temperature and pressure? Hello, Vanessa.
I haven't done that, teacher.
Yes, Vanessa. What is the volume of hydrogen gas produced at room temperature and pressure? I cannot hear your voice, Vanessa.
Is it 1.44 m3? M.
Yes, 1.44 dm cube. 1.44 dm cube. And then calculate the concentration of lithium hydroxide formed. Let me ask to T cell.
Yes, teacher.
Yes. What is the uh, concentration of lithium hydroxide formed?
0.24.
Yes, 0.24 mole per liter. Correct. Okay. D in when heated in chlorine, all the alkali metals react to form corresponding chloride. Describe what you see when sodium is heated with chlorine and what is the reaction. Okay, sodium react with chlorine. Let me ask Brian's. Hello, Brian's.
Yes, teacher.
Yeah, what happens when sodium reacts with chlorine? What
Mm,
observation?
uh, the sodium will turn white.
The sodium, the sodium chloride will,
Turn white.
yeah, become white white gas or white liquid or white crystal. The sodium chloride. What is the color of sodium chloride? White. What is the form of sodium chloride? Is it solid, liquid, or gas?
Gas.
Huh? No, solid.
Solid.
Yeah, sodium chloride is table salt, Brian.
Oh, okay.
Sodium chloride is table salt. So the what is the equation? The equation is the equation.
NaCl.
Yeah, that is the sodium chloride. So over here there must be Na, Na. Oh wait, let me write properly. So there is here NaCl. It becomes NaCl. Okay, and then this one is Na plus Cl atom or Cl2, Brian?
Cl. Atom.
No, Cl2. Chlorine at room temperature it must exist as diatomic molecule. So Cl2. And then balancing, this is 2, and then this one 2. What is the state at room temperature of sodium? Solid or liquid or crystal? Solid or liquid or gas?
Solid.
Solid. Solid. And then what is the stick for chlorine?
Gas.
Gas. And then what is the state for sodium chloride?
Solid.
Solid. Yeah. Okay. Sodium crystal is very reactive. It can explode with water vapor. But sodium chloride is becoming unreactive and it has very high boiling and melting point. Okay, next, this one. Okay, first ionization energy, you know the term. Ariella had told us, write an equation which states symbol the second ionization energy of element X. Second ionization energy of element X. Let me ask Sherry. Sherry? Yes? What is the chemical equation for the second ionization energy of X?
X plus equals to X2 plus.
Yeah. So, Cherry, what is the chemical equation?
X plus equals to X2 plus E minus.
Yes, correct. So X plus become X2 plus E minus, second ionization energy. And then use the data here given above to deduce in which group of the predictable element X is placed. Explain your answer. So from this one, from this first from the successive ionization energy, from the successive, this one, you have to make, you have to deduce in which group is this element X. Let me ask to Clarabella. Hello, Clarabella.
Yes, teacher.
Yeah. So, what is the group of this element that has this? What is the method? Can you tell
Group
us?
5.
Can you tell us what is the method? Yeah.
Is it in group 5?
Why is it in group 5? How to do it? How to do it? Clarabella? Yes. Hello, Clarabella. So the method here, the method of this one, you have to make into log base 10. All these numbers you have to make into log base 10. Log base 10, all these numbers, and then also with this one. Okay, log base 10. Okay, let me ask help from Eric. Hello. Oh, or still Clarabella. Clarabella, do you have calculator in front of you?
Yes, teacher.
Yeah. What is the log base 10 of 950?
Sorry, teacher.
What is the value of log base 10 950? So log 950.
Wait, teacher.
Yeah. Okay. Log 950. Log 950. What is the value? Yes.
2.9. 2.97. 2.98.
2.98. Okay. And then what is the log 10 of 1800? Log 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 1800.
4.96.
4 point 4 point
3.3.
3.3 or 4? 3.3.
3.3.
Three significant figure, please.
3.28.
To 3.28. Okay, 3.8. And then what is the log 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 2700?
3.43.
3.3 or 14?
4.3.
Oh, 43. Okay. And then what is the log? What is the log of 4800?
3.68.
Yeah, 3.68. And then log of 6000.
3.78.
3.78. And then what is the log to 12,300?
4.09.
4.09. Okay. From here, from 2000, from 2.98 become 3.28. What is the difference? 3.28 minus 2.98, 0.3, right? And then so we
Yes.
have to keep on doing the difference, and difference. Okay, so this one difference is 0.3, and then here 3.28 minus 3.43, 0.19, and then here 3.43 minus 3 minus 3.68, 0 this one 0.25, and then this one from here to here is from here to this one is 0.10. Am I right? 0.1. Am I right, Clarabella? 3.68 become 3.78 is 0.1, and then 3.78 minus 4.09, it is 0.31. Oh, sorry, wait, this 31, and then here here, wait. So here 0.31. From this from this all parabela, which one is having the highest difference from 5 to 6? Am I right, parabela?
Yes, teacher.
Yeah. So it means the outermost has 5 electrons. It is group 5. That is where it came from. So we have to make into log number, because logarithmic number it becomes smaller. Very small number, easy to calculate. And then we find the difference between each number, and then the highest difference, it means the internal electron is being taken out. So if the internal is taken out, then we know how many electrons are there in the outermost shell. Okay, so that is the explanation behind it. Next question. The
Teacher.
first ionization energy, for group 4 is given below. Explain trend shown by these values in terms of atomic structure of the elements. Atomic structure. Now let me ask to Felicia. Hello, Felicia.
Yes, teacher.
Yeah, Felicia. What is the structure of carbon?
Structure.
What is the structure of carbon?
Structure as if in what, teacher?
Now, the structure of the elements in terms of
Like
atomic
ionic
structure.
or layered?
If there is this kind of question, how can you, what is your interpretation?
The
Explain
arrangement like ionic or covalent like that?
if there is this kind of question, Felicia, what is your interpretation? What does it mean by the question? Explain the trend shown by these values in terms of atomic structure or atomic structure of the elements. It worth 4 marks. Is worth for 4 marks. It was in 2005. Yes.
Allowed to.
Yes, Nathan.
Then the trend showing that as you go to the right, there is like a decreasing in the first ionization energy required. So
Yes.
what I can see from here is as you go to the right of this table, you see that the element is placed going to the bottom of the periodic table. That
Yes.
will explain.
So it is down the group.
Yes.
Yeah. And then
And then as you go down the group, you will see this pattern in which the diameter of the atoms will become larger due to the larger number of shells.
exactly. And then
All right then. So next we can see there's an anomaly Sn and Pb, strontium and lead. This is because lead, if we see the box thingy, the box rule, we see that lead will have like two in one of the boxes. It will have two alternating, two electrons that are alternating, while strontium will have just only one, 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 one.
Yes, it is tin.
Oh,
Yeah, Sn is tin.
Tin.
Yeah, next. Continue, Nathan.
Just one more. Mm, all right then. And then the other one will be very simple. As we go to the right of the periodic table, you will see that the atom will go also smaller. So it moves upwards and rightwards. It means that it is going smaller. So it means smaller means require higher amount of energy
Mm-hmm.
to have it. So we see that, for example, carbon right here. Carbon is located at group 4A, which is at the right side, almost at the right side of the periodic table. So that's why it requires higher amount of energy in order to break off. While lead, let me search lead in the periodic table. Let me
Yes.
search it. Lead in number what? Lead in periodic table. Lead is basically located. Wait a minute. So let me get an example. Sn tin. Tin is located at the middle. So we are given with the table that if you go to the left, it requires less amount of energy in order to ionize, while going to the right, we require more amount of energy.
Okay.
That's it. I don't know anymore. I don't know how to explain it anymore, sir.
How do
That's
you
it.
relate shielding effect?
Shielding effect.
Yeah, there has to be word shielding effect because for marks, of course, they the A level examiner will find the keyword, will find only keywords. What is the shielding effect? Nuclear charge, and then atomic radius, and then electron shell.
Okay. So I just got two.
Yes.
That's require shielding effect.
You, I heard from your discussion, you give a discussion about the goes across the period. It is
Mhm.
not allowed. Why? Because in here is only describing down the group. Do not relate with across the period.
Ah, okay,
Teacher,
sir.
Yes, Felicia.
may I answer then?
Yeah.
If it relates with the atomic radius, that means down the group there are more electrons present. So there will be more electron shells, which
Yes.
leads to a greater radius of the atom.
Yes.
So with this increase in the radius, there will be more shielding effect,
Correct.
and so the nuclear charge decreases.
Yes.
And then it will be easier to extract the electrons. That's why it only requires a lower amount of ionization energy.
Yes. So with tin and lead, Nathan's explanation was correct. Did you mention? I heard you mention about tin and lead, about the electrons in the orbital.
Mhm.
So generally decreases, but there is an exception to it. The exception is located between tin and lead. Okay, tin and lead is because of the electrons in the orbitals, the electron spinning. Okay, so I'm sure you can. I'm sure you are drawing the electron and then the spinning. You will see. Okay, next this one. In the 19th and 20th centuries, scientists established the atomic theory and showed that the three subatomic particles, electron, neutron, and proton, exist. the masses and charges of these three particles were subsequently determined. When separate beams of electrons, neutrons, and protons are passed through an electric field in the apparatus below, they behave differently. They behave differently, and then which of these three particles will be deflected the most by electric field? Let me ask Kimberly. Kimberly, which of these three particles will be deflected the most by electric field?
Wait, teacher.
Yes. Oh, okay.
Electron.
Yes?
Electron.
Yes, correct. In which direction will this particle be deflected?
The positive side.
Yes, correct. Why is it like that?
Because electron have negative charge, so it will attract to the positive side.
Yeah, correct. And secondly, while proton is also deflected to the negative, but electron is the most because electron is very light. Very light. It has very small mass, tiny mass. Okay. Define the term proton number. Proton is the proton number is the number of proton in the nucleus of the atom. B2. Explain why is the proton number of an atom of an element is usually different from the nucleon number of an atom of the element. The proton number is different from the nucleon of an atom of the element. Maybe I'd like to ask to Timothy. Hello, Timothy.
Yes, teacher.
Why is the proton of an atom of an element usually different from the nucleon of an atom of the element? Different from the nucleon. What is nucleon number?
Nucleon number is equal to the total number of nucleons.
Nucleon is equal to the
total number of protons and neutrons in the nucleus.
Yes, correct. Why is proton number of an element is different from the nucleon number of the same element? Because there is a presence of
protons.
No. Why is the proton number of an element different from the nucleon number of the same element? Because there is a neutron.
Oh,
You
neutron.
stated that nucleon consisting of proton and neutron. The question is asking why is the proton number different from the nucleon? Because there is a presence of neutrons. Okay, and then next, the last page. Protons and neutrons have been used in nuclear reactions which result in the formation of artificial elements. In such process, protons or neutrons are accelerated to high speeds and then fired like bullets at the nucleus of an atom of an element. Suggests why neutrons are more effective than protons neutrons more effective than protons as nuclear bullets. It's short because let me ask Natasha.
Yes, teacher.
Natasha, why is neutrons more effective than protons as nuclear bullets?
Um, is it something have to do with the charge?
Yes. Is it worth to mark?
It's because neutrons are um have no charge.
Yes.
They are
Second point.
neutral.
Yeah. If it does not have charge, therefore the neutrons will not be
They're not affected by
the protons. Yeah, will
yeah.
not be affected by the protons in the nucleus of atom. Okay, Natasha. D. In some cases, when neutrons are fired at atoms of an element, the neutrons become part of the nucleus of those atoms. What effect does the presence of an extra neutron have on the chemical properties of new atoms formed? What is the effect? What is the effect of the extra neutron have on the chemical properties of new atoms formed? Let me ask to Hardy. Yeah, forgot. Hardy was there. Hardy. Hello, Hardy.
Yes, teacher.
What effect does the presence of extra neutron have on the chemical properties of the new atoms formed?
Uh,
What effect? What is the effect?
effect.
Yes. What is the effect, Hardy?
It will affect its atomic mass.
No, the question is asking for chemical property. What is the effect on the chemical property? Not the physical property. Atomic mass is physical property.
Oh,
Yes, Hardy?
don't know, sir.
Yeah? There is no effect.
I don't know.
There is no effect because the chemical property is based on the number of electrons, not based on the number of neutrons, because neutrons does not have any charge. Okay, so this is the review for atomic structure, for structure of atoms, and then on I'm planning this Friday we are going to have test for this chapter 2. So Wednesday and Thursday we are going to have reviews. Okay, so our review for each chapter take longer time than the theory because review requires more discussion. Is there any question? Felicia, maybe you want to ask?
No, teacher.
Are you sure, Felicia?
Yes.
Nathan V?
I understood, sir. I understood.
Okay. Okay, so let me ask Vedika. Is there any question, Vedika?
No, teacher.
No. Bavia?
No, teacher.
No. Okay. Brian, is there any question?
Teacher.
No. Okay. So if I asked already more than 3 students, most of your friends do not have questions. So I'll discuss again uh, different questions about atomic structure tomorrow. Okay. Now you can have your lunch, and I'll talk to you again. Discuss tomorrow. Okay. Good morning. Good afternoon, students. You may
Thank you, teacher.
sign
Yes,
up.
sir.
Thank you, teacher.
Teacher.
Thank you, teacher.
Thank
Yeah,
you, teacher.
welcome.